Welcome, everybody. Thank you for coming today to CDK Day. This is the CDK8s talk, or how you can use constructs to build out your Kubernetes resources. My name is Matthew Bonig. This is going to be a lightning talk. This is going to be very quick. I'm going to breeze through a lot of things. There are blog articles and code samples for all of it, and I will be posting links to those in the Slack channel. So let's get started with a little bit of background. The AWS CDK was released last year as an alternative to CloudFormation in creating infrastructure as code. It allows you to define your infrastructure using the idea of a construct. And a construct may be something as small as an S3 bucket, or it could be an entire application stack. You wire these constructs together. It doesn't really matter how big or how small they are. The API still works the same regardless. So in this case, with the AWS CDK, we're going to start off with L1 constructs that are generated from the CloudFormation spec and are one-to-one mapping with those things. You never usually deal with CloudFormation L1 constructs directly, so we always deal with L2 constructs in most situations, and these are wrappers around the L1 constructs. They give us just a nicer interface to work with, some helper functions, things that take care of common security concerns or wiring things together in a nice way. And then from those L2 constructs, you can build an L3 construct, which combines multiple L2 constructs together to build out an entire, sort of microservice or application stack. This is an example of a simple GraphQL service. This image comes courtesy of the CDK patterns project. If you're not familiar with them, I highly recommend you check them out. They take common serverless architecture patterns and create CDK examples for you to learn from. In this case, this would be a GraphQL service that's made up of an AppSync resource, an AWS Lambda, and a DynamoDB. So this would be packaged into a construct that could easily be distributed out to your teams, and they wouldn't have to know the internal workings of these things. They just know, okay, this will give me a GraphQL service on AWS serverless. So how does this relate to Kubernetes and infrastructure as code? Well, from this, Kubernetes already has actually infrastructure as code in the form of manifest files. But manifest files are very flat, they're very static, they're very easy to read, but they're not very reusable, and they're not very dry. So from that, you go on to Helm charts, and Helm charts solve some of the problems with that, but they introduce their own problems too along the way. This is all using a standard YAML format with Go templating along the way, and if you're not familiar with Go, you'll probably have to learn a lot of syntax along the way. But then there are some things in here that are just sort of annoying that you have to concern yourself with. Things like calling specific to YAML functions so that a variable that was passed in gets rendered out as YAML, and then because it's YAML and it's white space dependent, you have to make sure that indentation is really correct. And these things can be very painful to maintain over time. Very large, they don't solve common problems like good refactoring or good reuse of code. Now, when it comes to testing, you're kind of limited in this case. You can do a very simple test by running a Helm template command, which will take that Helm chart and try to render the YAML from it. If it succeeds, then great, you have syntactically correct YAML and a Helm chart, but it doesn't really do any functional testing to make sure that a variable provided over here ends up in the right place in the YAML file. So the other option is to go through automated testing, but these automated tests can be very hard to work up, and they require running Kubernetes cluster because they're ultimately integration tests. So at the end, you end up with these Helm charts that are really hard to read, they're really hard to change, hard to test, and which means they're really, really hard to maintain long term. So how do constructs aim to fix this? Well, we'll start off with a deployment construct here, which is, this is coming from the CDK8s plus library. It is a L2 construct, which I just provide over kind of our common replica count, containers, those sorts of things that you're familiar with creating a deployment. And then it gets this expose function. And internally, when I call this expose, it'll create a service for me that's automatically wired up with the deployment and everything. So once I have all these constructs built, I pass it to a synthesize routine, which will then spit out a bunch of YAML that I can then hand over to Kubernetes using a kubectl command or GitOps or whatever your normal CI/CD pipeline is for these types of things. So with CDK8s, we go ahead and L1 constructs are generated from the Kubernetes resources or from CRDs that you provide. L2 constructs you can either create, or you can leverage CDK8s plus L2 constructs from that library to build out your L3 constructs, which might be entire application stacks. This is an example of a MERN chart that I built this year for a Kubernetes cluster that I manage that has like 3 or 4 running MERN applications in it. So in this case, this chart will create me an issuer for all my certificates. It'll create an ingress for my public accessibility, and then I've got a deployment and a service, and these things all get wired together. And at the end, it spits out all of this YAML that I can just then kubectl apply it to my Kubernetes cluster. And every time that I run that synthesize routine, I'll hand over different variables, and it'll spit out slightly different YAML along the way. So what are the benefits of this? Why would you really want to do this? Well, one of the benefits of the constructs and CDK8s is that they're multilingual. You can write these in Java, TypeScript to JavaScript, or Python. And that's actually a really big deal because normally your application developers are the ones who are probably going to be maintaining these charts in a lot of situations. And there aren't still a lot of Go developers out there. And a lot of these situations that I've run into, there's still Python and Java developers. So when a Python and Java or TypeScript developer has to context switch over into Golang to work up these templating languages and things, it can be very painful. So being able to write this in the languages that I'm already familiar with is a big boon to that productivity and a big benefit to it. But also, this is all unit testable. It's very easy for me to write a unit test that verifies that my construct is generating what I want it to generate, and I don't need a Kubernetes resource cluster to actually verify any of that. And this is all just wonderful, fantastic magic that we've been accustomed to on the AWS CDK, and it is now available with Kubernetes in the CDK8s project. So let's say I've convinced you. Let's say you want to start adopting this. How would you actually go about doing it? Well, it's actually not too bad thanks to the fact that Kubernetes is naturally infrastructure as code already with manifests. First thing we're going to do is we're going to import any of the resource definitions or CRDs that are important to us and our particular cluster. And then I'm going to start snapshotting out the resources that already exist in that cluster and save those off as JSON files. I'm going to write unit tests that leverage those snapshots to verify that the constructs I'm about to build match those existing resources. And then I go and I implement my constructs. So defining those imports is really simple. There's a file within the CDK8s project in which I specify that I want to pull in the standard Kubernetes resource definitions. I could also version tag this with just an @1.14.0, so I can pull in specific versions of those resource definitions. I can also point it at publicly available CRDs, or I can point it at CRDs which I have defined ourselves as an organization. Once these are defined as these imports, all of those L1 constructs will get generated in the CDK8s project, and you can leverage them to continue building out constructs. As far as getting snapshots, it's really simple. You just go to kubectl and you ask it for the JSON definition of a particular resource, and then you save that over into a snapshot file. The unit test then just reads in that snapshot and verifies that the constructs and the charts that you've been creating in the CDK8s match what you've already got, and then you go implementing with your TDD approach. And then you just repeat that snapshot and unit test and implementation process for each of the resources that you have in your particular application: ingress, deployment, service, so on and so forth. Now, this is all great and everything, but the CDK8s and CDK8s Plus are technically still in alpha. So a little caution in adopting them. They've learned a lot from the AWS CDK, and it is a fairly stable API right now. You're not going to see any major changes, but it is still alpha and it's a preview release, so be careful with it. Don't expect to be replacing all of your infrastructure as code with the CDK8s right away. But I do recommend, if you're using Kubernetes, give it a look, see if it's going to fit nicely into your organization, if you're going to benefit from these things that we've talked about. So that's it. I'm going to be available all day in Q&A on the Slack channel. If you have any questions, please feel free to reach out to me there, or you can always DM me as well. Thank you again for coming today. I hope you have a great day at CDK Day, and I'll see you in a minute.